Hi everyone, I'm Mrs. Page and welcome to this GCSE chemistry lesson. Here we go. So, as I said, this is our first GCSE chemistry lesson. If you have already been in this lesson, so if you were in the live Zoom session with me, then you are very welcome to watch this again. There are a couple of other questions that I added, but it will be very similar, so you don't have to. Okay, this is for people who missed that Zoom session because I know not everybody was able to get online. So the learning question we are going to be looking at is, what are atoms? All right, and for this lesson, you will need a pen and some paper or a notepad, and you will also need a calculator. So if you don't have those things, then go and pause the video and go and grab them now. You also need somewhere with a little bit of space to work, and I know it's very difficult, especially at the moment, but somewhere with not any distractions if possible. Okay, so let's get started then. So I've got to do it now for us here, which is, what is an atom made up of? And I've given you a couple of key words as a hint there. So what's an atom made up of? So we know that atoms are very, very tiny, but they are made up of things that are even smaller. So if you can pause the video now and just maybe make a little brainstorm or a little mind map with any words that you can think of what makes an atom. Well done. Okay, so we will save or park that knowledge about what an atom is made of for now, and we'll come back to it in the next slide. Okay, first of all, we're just going to have a quick look at the history of what we know about the atom. So first of all, the first person to really start talking about atoms was a scientist called Dalton. And he knew that everything was made up of atoms and that atoms made up different elements, but he thought they were solid spheres. Okay. Then Thomson started looking at the atom, and he thought that they contained electrons dotted in amongst the atom, like the fruit in a plum pudding. Now, plum pudding is a pudding from years ago, so we don't really have plum pudding anymore, but I like to think of it as like the fruit in a Christmas cake. So the electrons were dotted around like the bits of fruit in a Christmas cake. That's what he thought. That's why it's called the plum pudding model. Then Rutherford did some really, really important experiments that you might have heard of. These experiments involved firing particles at gold foil, so firing subatomic particles at gold foil. Now, what he found was that some of these particles were able to pass through the foil. So that meant that actually an atom couldn't be a solid sphere, otherwise nothing would be able to pass through. Part of the atom must be made up of empty space. So he was the first person to discover that a lot of the atom is empty space. He also discovered that atoms have a positive nucleus, because the positive particles that he was firing at this gold foil, some of them got deflected back off again. So he knew that the different parts of the atom had different charges. The next person to really think about it was Bohr. And he was the first person to think about electrons being in shells, what we call shells. You know, sometimes in the drawing, we'll see a drawing of an atom in a moment, but you know, in a drawing, they show the shells around the atom, and the electrons are orbiting the atom in shells, kind of like how the planets orbit the sun in the solar system. And then we are on to Chadwick. So he really started thinking about what's in the nucleus. So what is inside the nucleus? And he started thinking about the different particles inside the nucleus of an atom. And that brings us up to modern times. And we know a lot more about the atom than we did, for example, back in Dalton's time. But there's still a lot that we don't know. So scientists are constantly experimenting and trying to find out more about the atom. And our ideas are kind of changing as we do find out more. So we modify and change our model of the atom to fit, the evidence that we've got. Okay. So here is the familiar picture of the atom. Okay, and hopefully some of the keywords that you wrote down in the Do It Now activity, hopefully you will be able to use them, and you'll hear me mentioning them when we talk about the structure of the atom. So inside the atom, we've got the nucleus. And the nucleus is made up of protons and neutrons. And spinning around the outside in these shells are electrons. Now, electrons, the electrons spinning in the shells, there can only be a certain number in each shell. Now, in the first shell of an atom, can only hold up to 2 electrons. So that's why there are 2 electrons here in this first shell. The second shell can hold up to 8. This isn't a full shell though. In this picture of an atom, there's only 4. So it's in group 4, we know, but it's not a full shell because the second shells and the other shells can hold up to 8. So the protons and the neutrons both have a mass of 1. You can see this in this table I've got here. So the protons and the neutrons have got a mass of 1. Electrons have got such a tiny mass that usually we just say negligible. So it doesn't really count, all right? Protons have got a +1 charge, so a positive charge. Neutrons, the clue's in the name really. Neutron sounds like neutral, doesn't it? Or no charge. So yeah, neutrons have got a charge of 0. And electrons have got a charge of -1, so they've got a negative charge. So when we are looking at the periodic table, so we'll study the periodic table in a minute, but when we're looking at an atom, an element in the periodic table, there are 2 numbers that are really important and allow us to work out how many protons, neutrons and electrons are in an atom. The first of these numbers is the smaller number, which is the atomic number. Now the atomic number is just the number of protons. Okay, so that's the number of protons inside the nucleus of the atom. The second number, the mass number, is always the bigger number. So the bigger number is the number of protons and neutrons. So protons and neutrons added together. So we can work out how many of each of these subatomic particles are inside an atom. So the number of protons, that's the easy one. That's just the atomic number. The number of electrons is always the same as the atomic number, unless the atom has bonded with something else or unless it's become an ion. The atomic number will always be the number of protons and the number of electrons. Now, an easy way to remember this is to think of an atom like a seesaw. So it needs to have the same number of positive and negative charges inside it to balance out this seesaw. So for example, carbon has got 6 protons, okay? It needs to have 6 electrons to be able to balance out that positive negative seesaw, okay? Because atoms are always neutral. And there is a calculation that you can do to calculate the number of neutrons in an atom. It's the mass number, which is, remember, the number of protons and the number of neutrons. So it's that mass number, take away the atomic number, which is the number of protons. So you've got the protons and the neutrons, you take away the atomic number, which was the protons, and you get left with just the number of neutrons. So you can work out the number of neutrons by doing the mass number take away the atomic number. Okay, so here is our first couple of practice questions. Now, there are 2 practice questions here for you to have a go at. If you're feeling really confident, then you can have a go at the silver and the gold. If you're not feeling quite so confident, then just have a go at the silver one. Okay, if you look at the silver one and you think that's actually really easy, then don't worry, just go straight on to the gold. Okay, so pause the video now and have a go at these questions, and then we will mark them in a moment. Fantastic, well done. So get your pencil ready or your pen to tick your correct answers. And it might be really useful if you correct your wrong answers, then that will help you know where you went wrong and hopefully get it right in the future. So this aluminium atom here, it has a mass number of 27, an atomic number of 13. So we know that the number of protons, which is 13, because the atomic number is 13, the number of neutrons, remember the number of neutrons is the mass number, so the larger number here, take away the minus the atomic number here. So 27 take away 13 is 14, so number of neutrons, 14. Number of electrons has to be the same as the number of protons, remember, otherwise that seesaw wouldn't balance. So the number of electrons is 13. Now, the next question was why an atom has no overall charge, referring to these subatomic particles that we've just learnt about. So the answer to this is because an atom contains protons, neutrons and electrons. Protons have got a positive charge, electrons have got a negative charge, so they balance out, and neutrons have got no charge. Okay, and there's an equal number of protons and electrons to balance the atom out to neutral. Okay, so we're going to have a quick look now at the periodic table. So this is where you can find all of the elements that we've discovered on Earth will be here in this periodic table. Some of them are much more common than others, and some of them are much more stable than others. Okay, so some of them don't exist for longer than a very short time in the atmosphere without reacting, but all of the elements that we've ever discovered are here. So you probably already know that each element has got a chemical symbol. So that's either a capital letter or a capital letter and lowercase letter. Okay, that's the chemical symbol, and each of the elements has a different chemical symbol. You've got the atomic number, like we talked about, which tells you how many protons are in the element. And you've got the relative atomic mass, which tells you the mean mass. So we'll go on to talk about why that's the mean mass in just a moment, okay? But that's the mass number. You've got columns in the periodic table that we call groups. And each group contains elements with similar physical and chemical properties. All right, so they're all very similar. They react in the same way. They behave in the same way. They might look similar. All right, so each of these groups has a different kind of similar chemical properties. All right, and you've got these numbers at the top here that tell you how many electrons are in the outer shell of the elements in that group. So for example, group 1 all have 1 electron in their outer shell. Group 2 have 2 electrons in their outer shell. Group 3, you've got the idea. Okay, these elements here in the middle that don't have a number on top of them, they are the transition metals. Okay, so they're all the metals there. And then groups 1, 2, 3, 4, 5, 6, 7 and 0, which confusingly is sometimes called group 8 because these atoms have 8 electrons in their outer shell. Okay, and we've got rows of elements of increasing atomic mass. So as you go along the rows, the atomic mass gets bigger and bigger, and we call those periods. And the periods tell us how many shells an atom will have. So we know that everything in this first period, so hydrogen and helium, will just have that one shell. And then as you go down and increase in period number, the number of shells in the atom will increase. So the atoms get larger as you go down the periodic table. Okay, if at any point I am going too quickly for you, then if you just pause the video, you can either rewind and listen to me again, or if you prefer not to hear my voice for a little while, you can go to BBC Bitesize, and I've put down below on some of the slides just to remind you when you could possibly pause if you needed to and go to BBC Bitesize. Just remember to type in Edexcel Science, because that's the exam board that we do at school. Okay, here is a 6-mark question for you to have a go at. So it's describe how the arrangement of elements in the periodic table is related to the atomic structure of their atoms. So you need to be thinking about what I was talking about, groups and periods there. So what I would like you to do, ideally, is if you can go to this website, which is the website for Shobi, which allows you to submit work to me. You sign up to that, which is very, very quick and easy to do. Join the class by adding this class code quickly. And then if you could, the assignment of this question is already there. If you could type out an answer into that, then myself or one of the other science teachers will be able to read it and mark it and give you some feedback, which would be so nice, because we're really missing like that communication with you. And it's been really strange not being able to kind of help you learn as we usually do. So that would be really great. Instructions of how to do that are also on class charts as well. So I've set this assignment on class charts, and it's set on Shobi for you to submit your answers. Okay. Okay, moving on then, we're going to look at what is meant by the term isotope. So an isotope is an atom with the same atomic number, so the same number of protons, but a different mass number, because there's a different number of neutrons. They have the same number of protons, but different number of neutrons. And here in this picture, you can see that these are all atoms of hydrogen, but they each have a different amount of neutrons. So this one here doesn't have any neutrons. It just has a proton and an electron. This one here has 1 proton, 1 neutron, 1 electron. And this one here has 1 proton, 2 neutrons, and an electron. Remember, these are all still neutral atoms, because these particles with charges are the protons and electrons, and there's the same number of those in each. There's 1 of each in all of these. So these are all neutral atoms, but they're just isotopes of each other. They just have a different number of neutrons, and so a different mass number. Okay, so there's a question there for you to have a think about. You might have noticed, what would the mass number of these isotopes be? Just give you a sec to think about that. Okay, I'm sure you all were able to think about that brilliantly. So this one here, because this proton is the only particle that has a mass here, this atom would have a mass of 1. Here, there's a proton and a neutron. Both of those have a mass. Electrons don't, so it'd be a mass of 2. And here you have 1 proton, 2 neutrons, so a mass of 3. Okay, and if you can answer this question for me, so explain what is meant by the term isotopes. Now remember, this is worth 2 marks, so you need to kind of be writing 2 separate points, all right? So if you can pause the video now and have a go at that, that would be brilliant, and we'll mark it in a moment. Okay, and remember, there's always the BBC Bitesize website for you if you need a little bit of extra information about this, or just to go over something again. All right. Excellent. So isotopes are atoms of the same element. So they're always the same element because they've got the same number of protons, the same atomic number, which means they're the same element. So same number of protons, but a different number of neutrons. And that means that they have different mass numbers. Okay, so give yourself a tick if you got those right. Okay, the next thing that we're going to look at, we've got two more things to look at, ions, and then we'll look a little bit at ionic bonding. Okay, so you're doing really well. An ion is an atom or a group of atoms with a positive or a negative charge. And the way that an ion forms, the way an atom gets this positive or negative charge is by either losing electrons or gaining them. And often atoms will do this to obtain a full outer shell. Atoms really want a full outer shell because that's how they are most stable. So that's how they are most stable. So they always want to get a full outer shell. So here's an example of a sodium atom forming a sodium ion. And what I would like you to do is, first of all, I'm going to talk through it. Then I would like you to have a go at drawing this out, this ion formation, so copying this picture. And then I would like you to answer that question in the yellow box, okay? So looking at this sodium atom then, at the moment, because sodium's in group 1 of the periodic table, it has 1 electron in its outer shell. To make sure that its outermost shell is full, it needs to get rid of that electron. So it loses that electron when it bonds with a different atom. It loses that electron. And because it's lost an electron, and electrons have a negative charge, the sodium atom has a positive charge, a positive 1 charge. Okay? So if you could now pause the video, copy out that diagram showing how a sodium ion is forming. If you could answer that question in the yellow box, that would be great. Fantastic, well done. So why does this ion have a positive charge? Because it's lost an electron and electrons are negative. Okay, so that would be your answer for that. Okay, can you describe in terms of electrons how a copper atom becomes a copper ion? So a copper atom is neutral. A copper ion has a 2+ charge. So can you explain how it changes into that ion in terms of electrons? So pause the video now, have a go at that. Remember, it's 2 marks, so you need 2 separate points. So you would get 1 mark and give yourself a big tick if you wrote anything about 2 electrons, the fact that there are 2 electrons involved in this ion formation. And another mark if you said that they are given away or lost from the copper. It's really important that you say that because that's what makes the copper that positive 2 charge. It's those negative electrons being lost. Okay, the next thing that we are going to look at is how to calculate the relative formula mass of a substance. Now, all you do is you look at the mass number of each of the atoms in the substance or in the compound, and you add them all up. Okay, it's as simple as that. Now, often students get a bit scared of any calculation questions in chemistry, but this is a nice and easy one to get marks for. So all you do, work out how many of each element are in the chemical formula, and we'll practice doing that together in a moment, and then add up those relative atomic mass values. That's what that AR stands for. Add up those values for all the atoms in the element. So let's have a look at a couple of practice questions about this then. So this question says, calculate the relative formula mass of calcium hydroxide. And it's giving you the formula of a molecule of calcium hydroxide there. So remember, the first thing that we do is work out how many atoms of each element are in the chemical formula. So let's have a go at that. So I know that we've got one calcium atom here. And I know that here, because these two atoms are in brackets, this is oxygen and hydrogen, because they're in a bracket with a 2 at the end, it means that everything inside that bracket is times by 2. So it's the same as in maths. When you have brackets in maths, you times everything in the bracket. Yeah, so I know that we've got 2 oxygens here and 2 hydrogens. So I know we've got 1 calcium, 2 oxygens, 2 hydrogens. And then all you need to do is then add those together, and that will give you the relative formula mass. So if you can pause the video, have a go at that. If you're super confident, have a go at the gold question below, okay? Fantastic. So I'm sure you all managed to do the first question. So they gave you the values here of the relative atomic masses. So calcium is 40, oxygen is 16, and hydrogen is 1. Oh, sorry. So all you do is 2 times 16, because remember there were 2 oxygens, 2 times 1, because remember there were 2 hydrogens, and add the 40 for the calcium. So you add those together, gives you 74. That's the relative formula mass. The second question said, a normal sample of chlorine only contains chlorine 35 and chlorine 37 atoms. So they're the mass number of the different isotopes of chlorine. Explain why the relative atomic mass of chlorine is 35.5. So the relative atomic mass is an average of the mass of all the isotopes present. And so therefore there must be more chlorine 35 than chlorine 37. Okay, don't worry if you didn't get that question. It's a higher level question to understand, so don't panic. Okay, we are doing fantastically, and we are on to the last thing that we're going to look at in this lesson. So we're going to have a look back at ionic bonding. Now, you've probably all studied this at some point, but I know it seems an absolute world away now. So ionic bonding is where an electron or a group of electrons will transfer from one atom to another, and this causes a bond between the 2 atoms. All right, and here we have an example. So this here is a sodium atom. Now sodium is in group 1, so it has 1 electron in its outer shell. And here is a chlorine atom. Chlorine is in group 7, so it's got 7 electrons in its outermost shell. Now what happens when these 2 atoms bond together is the electron from the outer shell of the sodium comes away, gets lost, and gets transferred to the chlorine. And that makes both the atoms really nice and happy and stable, because sodium now has a full outer shell, and so does chlorine. It has 8 in its outer shell. Okay. Now, when lots of atoms bond together in this way, we get what's called an ionic compound. So ionic compounds have got this regular arrangement called an ionic lattice. All right, and it's all these oppositely charged ions. So this could be the positive sodium ion that's been made here and the negative chlorine ion that's been made here. So you've got these oppositely charged ions next to each other. And if you had a look at that question there, how are the positive and negative ions held together? The ionic lattice is held together because each of these ions is oppositely charged to the one next to it. And because they've got opposite charges, opposites attract. Remember, you've probably seen that when you've used magnets in school. The opposite poles of the magnets attract together. So these opposite charges are attracting together, and that's what is holding all these atoms together. And we call these electrostatic forces. And the ionic lattice contains such a large number of ionic bonds that a lot of energy is needed to overcome them. So much energy that they've actually got a really high melting point, because it just needs so much thermal energy to break those apart. So they've got a high melting point and a high boiling point, and they are solid at room temperature. The other really important property of ionic compounds is that they conduct electricity when they're molten, so when they're melted, or when they're dissolved in water to form what we call an aqueous solution. Both of these processes, both the making it molten and dissolving it in water, both of those processes means that the ions inside them are free to move around. So when these ions can move around, they can carry a current or a charge. So that's how they can conduct electricity. Let's skip past that bit. Okay, this is, you might be pleased to hear, this is our last couple of practice questions. So, sodium reacts with chlorine to produce sodium chloride. So here you've got sodium plus chlorine gives you sodium chloride. And you can see this reaction happening there. So it's the same as the one that we were just looking at. Can you please write out these sentences and add in the missing words, add in the words that I've missed out of them. If you are feeling more confident, you can have a go at this gold question here, which is explain why chlorine is a gas at room temperature. So that's the gas chlorine. But sodium chloride, which remember is an ionic compound, why is sodium chloride a solid at room temperature? All right, so have a go, pause the video, have a go at these questions, and then we'll mark them in a moment. Fantastic, well done. So get your pens ready to give yourself some big ticks. I'm really proud of anyone that's watching this video and giving these questions their best shot. So a sodium atom changes into a sodium ion by losing an electron. A sodium ion has a positive charge because it's lost an electron, and electrons are negative. The ions in sodium chloride are held together by strong electrostatic forces. Okay, and the reason that chlorine is a gas at room temperature, but sodium chloride is a solid at room temperature, is because chlorine just has covalent bonds between its atoms, and they're really weak. So it has a really low boiling point. Sodium chloride is one of these ionic compounds that we've been talking about, isn't it? So it's got these really strong bonds between the oppositely charged ions. Remember, we looked at that lattice structure of the strong bonds between the oppositely charged ions. So therefore, it needs a lot of energy to break those bonds, and that means it has a high melting point. Okay, so it's a solid at room temperature. Okay. Well done, guys. Remember, there is that 6-mark question that I've set you to have a go at. And if you can manage to log into Shobi, so you'll need to sign up to Shobi, but it's super quick. And then you just use that class code that I've given you, which is also on class charts. And then if you could submit me an answer, that would be great, because I would love to read some of your answers, and then myself or one of the other science teachers can mark it for you and give you some feedback. All right. Anyway, thank you very much for watching, and hope you are all right, not too bored, not getting cabin fever at home. And I will see you soon.